Sketch each angle in standard position and then convert the angle in radians to degrees. Recall 180 degrees is equal to pi radians, and on the right we have several common angles, both in radians and degrees. When an angle is in standard position, the initial side is along the positive x-axis. If the angle is positive, the rotation is counterclockwise. If the angle is negative, the rotation is clockwise. First, we have negative 2 pi divided by 3 radians, or negative 2/3 pi radians. In standard position, the initial side is along the positive x-axis. From here, remember that pi divided by 3 radians, or 1/3 pi radians, is equal to 60 degrees, which means negative 1/3 pi radians is equal to negative 60 degrees. So let's count by negative 1/3 pi radians, or negative 60 degrees, as we rotate clockwise. We have negative 1/3 pi radians, or negative 60 degrees, and then negative 2/3 pi radians, which would be negative 120 degrees. This is the terminal side for negative 2 pi divided by 3 radians, which again is equal to negative 120 degrees. But let's go ahead and show the work. To convert from radians to degrees, we multiply by 180 degrees divided by pi. Simplifying before multiplying, pi divided by pi simplifies to 1. 3 and 180 share a common factor of 3. 3 divided by 3 is 1. 180 divided by 3 is 60. 180 degrees simplifies to 60 degrees. And we're left with negative 2 times 60 degrees, which is negative 120 degrees. Next, we have negative 7 pi divided by 4 radians, or negative 7/4 pi radians. We should recognize that negative 8 pi divided by 4 would be negative 2 pi radians, which would be 1 full rotation clockwise, and therefore negative 7/4 pi radians is going to be negative 1/4 pi radians short of 1 full rotation clockwise. Also remember, pi divided by 4, 1/4 pi radians is equal to 45 degrees. So one approach would be to start at the positive x-axis and then rotate clockwise by negative 1/4 pi radians, or negative 45 degrees. We have negative 1/4 pi, negative 2/4 pi, negative 3/4 pi, negative 4/4 pi, negative 5/4 pi, negative 6/4 pi, and finally negative 7/4 pi radians. The terminal side is here. Again, notice this is negative 1/4 pi radians short of negative 2 pi radians, which again we may recognize as negative 315 degrees, but let's go ahead and show the work. Negative 7 pi divided by 4 times 180 degrees divided by pi. Pi divided by pi simplifies to 1. 4 divided by 4 simplifies to 1. 180 degrees divided by 4 simplifies to 45 degrees. And negative 7 times 45 degrees is negative 315 degrees. Next, we have negative pi divided by 2 radians, or negative 1/2 pi radians. Recall, pi divided by 2 radians is 90 degrees, and therefore negative pi divided by 2 radians, or 1/2 pi radians, is equal to negative 90 degrees, which indicates in standard position the initial side is along the positive x-axis, and we rotate clockwise 1/4 of rotation. So this is going to be negative 90 degrees. But again, let's go ahead and show the work. Pi divided by pi simplifies to 1. 2 divided by 2 is equal to 1. 180 degrees divided by 2 is 90 degrees, leaving us with negative 1 times 90 degrees, which is negative 90 degrees. The last example is a little more challenging. We have negative 19 pi divided by 10 radians. We should recognize that negative 20 pi divided by 10 would be negative 2 pi, which would be 1 complete rotation clockwise. This indicates this angle is going to be negative 1/10 pi radians short of 1 complete rotation clockwise. For this example, though, let's convert to degrees first. Pi divided by pi simplifies to 1. 10 divided by 10 simplifies to 1. 180 degrees divided by 10 equals 18 degrees. Negative 19 times 18 degrees is equal to negative 342 degrees. So again, this emphasizes the angle is going to be negative 18 degrees short of 1 complete rotation clockwise. So the initial oscillate is along the positive x-axis, and I'll rotate clockwise negative 18 degrees short of one rotation, or negative 1/10 pi radians short of one rotation, which we'll say is approximately here. I hope you found this helpful.